In this screencast, I will demonstrate how to model a fault tree in FASTEN. Fault tree analysis, FTA, is a top-down failure analysis method in which an undesired state of a system is examined. This analysis method is mainly used in safety engineering to analyze and understand the logic leading to the undesired state. Let us get familiar with the basic functionality of FASTEN to model fault trees. Let us imagine that we want to analyze a cooling system of an engine. The cooling system is based on the pumping coolant to prevent the overheating of the engine. We can create a fault tree by choosing the menu, New FASTEN Root Node, then navigating to Safety Models and Safety Analyses, and finally select Fault Tree. An empty root node is created, which will contain the fault tree model. Let us name this root node Engine Overheating Analysis. We can add a description to the current fault tree containing in the inspector window. If we are working in a Git repository, we can add the two special words to our documentation, branch and commit hash. They will automatically print in the diagram the name of the current branch and the hash of the last commit. Let us maximize the diagram and start building the fault tree. We can construct the fault tree by using drag and drop of model elements from the diagram palette onto the diagram. The top event we want to analyze in our example is engine overheating. We then perform the analysis in a top-down fashion by investigating the possible causes for the overheating. Let us consider that the overheating occurs when too few coolant is reaching the engine, and this in turn can be caused by three causes: a pump malfunction, blocked pipe, or insufficiently open valve. The pump malfunction can be caused by a mechanical issue with the pump, lack of electrical power, or a software malfunction of the controller of the pump. For the moment, we model these causes as basic events, which are not decomposed anymore. The pipe blocked event we consider as undeveloped, meaning that it is for the time being not further analyzed. Another cause for insufficient coolant could be that the valve is insufficiently open. The valve insufficiently open event can be caused either by the fact that the open command is issued too late or by insufficient maintenance. The insufficient maintenance is further decomposed in two causes: the unqualified personnel and the lack of a proper quality assurance process. The tree might grow larger, and in this case we might want to modularize it by creating new root nodes dedicated for a certain branch. For doing this, we need to select an element of the tree and use an intention, Alt plus Enter, and select Extract Branch into Module menu. A new root node is automatically created, containing the branch of the fault tree we selected to extract. In the main fault tree, a new entity with type intermediate event is created. This will point to the extracted fault tree branch. We can change the color of an individual node of the tree by using an attribute. We might decide to change the type of a node. For example, we can convert an AND gate into an OR gate. The name, description, and the connections to the other entities are automatically copied. We can use this refactoring in order to refine a basic event. Let us detail the potential causes of a software error and model that the software error can be caused either by an error in the algorithm logic or an additional programming fault. We can change the view from the diagram to a plain textual notation. The model can be edited also in the textual notation. Let us connect the OR gate to the gate software error. Let us change back the notation into a diagram. Last but not least, we can add the newly created fault tree to the versioning control. By double-clicking on the newly added nodes, we can see the diff view in textual notation. In this case, that the nodes are newly added. In this way, we can construct, refine, and modify basic fault trees in FASTEN. Thank you for watching. See you at the next episode.